Today we are now in a situation where we can look forward, and we now are looking into the future, and we see that the prototype is actually working. It did what we said it should. It's very complicated to use. It demands a lot of skills from the operator. We have now trained dedicated operators from Aarbakke Innovation. And my wife actually said it very well when she saw what they were doing. Nobody else in this world can do this. And I said, yes, that's right, nobody else. I started this about 8 years ago, and it was a very simple idea. I could probably have explained it to a colleague in 5 minutes, but it's shown that the challenges that matters with actually building the tool that we're going to use to measure this parameter, this water pressure in the reservoir, it's very complicated. It became a tool that was 18 meters long, and I have learned to appreciate the tremendous amount of skills that needed from individuals to actually make your dream come true.
My name is Lilia Schubert, and I am project manager at Aarbakke Innovation. I joined the Hydrophilic project in August 2023, and that was the phase when we prepared the tool for the very first operational experience for the offshore pilot. The main activities in the workshop was redressing the tool, introducing improvements from the previous experience, and test it in the test chamber. One of my main tasks was to build up the team that goes offshore, to organize trainings, to bring them up to the level that they are confident to go offshore with the tool.
Jeg heter Helle. Jeg jobber som verksted- og felttekniker hos Aarbakke Innovation, og har jobbet med HLT rett over et år. Når vi kom på riggen, så var jo tullet egentlig ganske klart. Der skulle vi bare sjekke at alt var gått greit underveis på transport. Alle var veldig spente mens vi holdt på. Det var midt på natta, og vi var jo selvfølgelig veldig stolt og fornøyd.
Starting on the 11th, we prepared. We had some trouble with shear pins, so they used their creativity and they were able to make their own shear pins. So we sorted it out. We went down the well. Everything was working. All the parts of the tool were responding. We had full control over the tool. And then we finally started drilling into the wall of the well. We did the first attempt to measure. That didn't work. We didn't measure the pressure we hoped to. And then we tried again a little bit deeper. That also failed. We drilled as far as we could. We ran out of the drilling fluid, but we had half a liter left. But we tried again, and this time we spent longer. We let the probe sit on the surface, and there was things happening there. We tried different things, but you just let the probe sit on the surface, and it took more than 20 minutes. Then we started receiving the data we had been looking for so long. We saw that the water pressure in the probe was dropping, and that was really, really good. And then we measured twice afterwards, and we have learned this personality of the reservoir. We could do it again and again. So now we realize that we are able to do it. This will be like a shot in the arm for the oil and gas industry. We can make the most efficient energy producer in the world even more efficient. It will we need fewer wells. Time from discovery to production will be shorter. The environmental impact will of course be less since we have to drill fewer wells. And especially in high-cost environment like the North Sea and West of Africa and so on, this will make a big difference, because one well there is extremely expensive. We will go into the first discovery well, and we will harvest the final piece of information that you have never been able to find before. I think this is the fundament for an international high-tech company from Norway.